something about working with Android Studio, like you would have just created a project and run the basic app that was which has nothing but hello world in it. So I hope that everyone has done that. Let's look at what we'll be going to see in session 3. So today we'll look into what object-oriented programming is, and then we'll build a birthday card app. So once we finish these two, like you do after every session, go to the course mentioned in this slide, and you can earn your badge. Before we learn about object-oriented programming, let's look at first of all, let's look at building a birthday card app. Yeah. So the birthday card app is a very basic app where there is no interaction between the user and your Android app. It's just a simple app that displays some UI components. So what you'll be learning while creating this birthday card app. So you learn what are the elements such as views, view groups, layouts, text views, drawables, and all. And these stuff that you learn should be able to get you to build an app that is basic enough to just have you display good stuff, but without any instructions for now. So let's get started. As usual, you create an empty activity project using your Android Studio. Once you launch it, you click File, New Project, or if it's the first time you're launching it, you just click New Project. And once you get there, first let's look at what are the components of Android display. So the UI of any app that you see, it might have a number of things like texts, images, or a box where you enter text, or buttons and whatnot. So in Android, each of these elements is called a view. So almost anything that you see on the screen is a view. Like I said, the text, the boxes where you enter text, or the images, the buttons, the scrollables, or the animations, or anything, that everything is a view. And each of these has its own name. Like something which where you display text is called text view, or where you display image is called an image view, and much more. So all of these can be found in Android Studio. Like if you go to the layout section, or the main activity layout.xml, and you go to the design page, you can see that there is n number of layouts or n number of views that you can use in your Android app. So like I said, you can keep adding these views inside your the XML file, and the views would get populated on an Android app. So let's say you have some 10 to 15 views in one layout or in one screen. So how do you organize these? It's pretty difficult to arrange each and every 15 of these views. Like let's say you have an image and the description of the image in another image, and its description, and you have to display some text and whatnot. So for these to be easily managed, we have something called a view group. So view group is nothing but a container that has a lot of view objects in it. So you have certain properties for the view group, which you can use to control the views inside them, and you can also change the properties of the individual views. For example, this is a view group. I mean, there are two views inside it. Let's say the view that is square in shape is nothing but an image, and the one that is rectangular in shape is a description of that image. So these two are views, and these are enclosed in a view group. So usually this view group is the constraint layout, which we look at in the upcoming parts. So just remember that constraint layout is nothing but it's a kind of view group, which is nothing but a collection of views or something or a container that encloses these views and makes it act as one. So you would have seen the layout editor in your Android Studio. So that is basically something which helps you, look at how your Android app is going to look while you develop your Android app. So you can use that layout editor to drag around stuff and to experiment with it. So this is the layout editor view. Like you can see here, the common, you have the palette where you can select what type of view that you want to add to it or what view group that you want to add to your layout. And you can, on the right, you can see what are the views that are available for you to add them here. So you can use this method, to simply take it and drag it to the layout here or whatnot. So there is also something called a component tree here, if you can see that. So basically, the component tree, what it does is, it gives you an hierarchical structure of what are the stuff or what are the views inside your view group. So like you can see in this picture, there is just hello world, right? So this hello world is inside something, inside a view group. And what kind of view group is it? It's constraint layout. So you have a constraint layout, which is nothing but the entire screen. And inside the constraint layout, you have a text view which says hello world. So basically, this is the basic unit of what makes up the Android display. You can, then work with much more, and you can change the properties of it. You can increase the text size. You can change the text. You can change the color of the background, or you can change the color of the text. You can change its font and whatnot. So basically, this is how you insert some views into it, and you alter the properties of the views. And if you want to have two or more view groups in it, you can go for it. You can do whatever you want. Okay. So that is pretty much what is there to know about views and view groups. Now let's look at positioning the text view. So as you can see in the picture, they have changed the text "Hello World" to "Happy Birthday, Sam." Uh, so this text has to be placed somewhere, right? So it's not necessary that, as you saw in the "Hello World" thing, it should always be at the center. So it can be anywhere across the screen. Like what they do here, they drag a text view and they place it here. So you can also do the same thing. You can place it here. You can place it wherever you want. And that is fine when it comes to constraint layout. But when you explore a number of layouts like vertical layouts and all, it is not possible to place these wherever you want. But for now, when you use constraint layout, you can drag it anywhere across the screen and it wouldn't be much of an issue. So here, the Happy Birthday Sam is dragged and it's kept on the top left corner. And we have another text. It says "from Emma" on the bottom right corner. So till now, what they have done is they have opened the app, they have dragged some text views, and they've placed it on the top left corner and one on the top right corner, and they have edited the text. So next part is adding style to the text. So till now, I think it's pretty simple. So the adding style to the text is also pretty simple. First of all, what you have to do is you have to click the text view in your in the component tree. So let's go back to the component tree. Okay, so this is the component tree, and you have the constraint layout here. And inside the constraint layout, there is a text view. So once you click this text view, you will have this window coming up. Yeah, you will have this window that comes up. From there, what you have to do is the first thing that you can look at is text. So it's by default hello world or whatever. You have to change it to happy birthday Sam. And as you can see in the next upcoming fields, the next thing is content description. You can give a description of it, which will not be displayed. It's up to you what description you give. It's not necessary. And the font family, you can change the font of the whole text view, and you have typeface, text size, line spacing, text color, text style, alignment, and whatnot. So if you want to alter the properties of this text view, you just click the text view from the component tree, and you get this attributes window where you can alter the properties of it, and you can make it however you want. So they have increased the size of the text view, and they've changed the font family, and you can also change the background color. Yeah, you can change the background color. They have increased the font size of this as well. So that's it for the basic building of adding two text views to it. Uh, yeah, let's look at how we can add an image next to it. Okay, so till now we have seen out how do you add two text views inside a layout. So now let's look how do you add an image. So the setting up your app part was already done, and how do you add an image? Yeah. So just go to this page, like as I've mentioned, the link is there in the slide. You can read through this once again, and you can understand it, and you can at the same time experiment with it in your Android Studio. So what you'll be using is you'll be using a resource manager first of all. So you just go to View Tool Windows and Resource Manager to launch your Resource Manager, and you can from the resource manager you import drawables. So what is a drawable? A drawable is nothing but an image or anything that can be displayed as a graphic in Android. So it might be a GIF, or it might be anything. So any graphic that you want to use in Android becomes a drawable. So you import drawable, and you select the image that you want to import into your app. So now if the image gets added into your app, uh, you can see that in the drawables folder. So the drawables folder, when you go to your project tab, you can find the resources folder. Inside it, you'll have the drawables folder, and inside it, you'll have all your resources in your Android app. So like you can see, the Android portrait JPG is inside the drawables folder. Once you import it using the resource manager. Next is adding an image view. So like you might have seen, it's as simple as as simple as adding the text view from the palette to your layout. The same way you can just drag the image view and you can add it here. Yeah, there is a animation where they've added it. Pretty simple way. You just drag the image view into your layout. Once you do that, you click the image that is already present in your resource manager, and your image would get displayed here. Now, position and size of the image view. So you can drag the size of the, you can drag the corners of the image, and you can place it where you want your image to be. This is possible with constraint layout. It's very simple with constraint layout. Yeah, and you can do a lot of stuff with the dragging and dropping, and like the same way we went to the attributes of the text view, you can also go to the attributes of the image view, and you can do a much more even there. Yeah, so we saw the attributes of the text, like text size, the text font, and whatnot. The same way you can edit the properties of the image view as well, like the scale type is center or fit center, or occupy the entire layout, or you can scale the image, you can crop the image, you can change its alpha so that it's partially visible, or you can explore whatever the options they give in these properties tab as well. So I would like to go back to the component tree again. So if you look at it now, you'll have a text view that says Happy Birthday Sam, another text view that says from Emma, and an image. So this is not how your app is supposed to look. So as you can see in this image, there are two text views, and your image should come below both of these. So what you do is you click the image view in your component tree, and you just drag it, on top of both of these text views, as you can see in this animation. You just click it and you drag it on top of these two. So what happens is that your image gets displayed first, and then on top of it, your two text views come on top of it. So that is one of the advantages of having a component tree, because it tells you which gets displayed first and which is on top of what. So some of the good coding practices are you're not having something called hard coded strings. We look at it later. I'll show you what that means and how you can rectify that. Uh, these are the things that you have to worry till now. Just don't bother about the rest. Once this is over, just go through all of these and try it out with Android Studio as soon as you can. I'll also show you once after this session is done about how to create your own birthday this app that they are showing here. You also try it out as if you can. Okay, so let's go back to the slides. Now we have seen how to build a birthday card app. It might not be very clear right now because I just showed you what is given in the official tutorial of the Google course. I'll also do it myself, and I'll show it to you a bit later. First, let's look at what object-oriented programming is. If you're new to programming, or if you have very little experience with programming, object-oriented programming might be very confusing and very intimidating at first. It's another simple concept, or if you listen to this very closely, it is very simple and you can learn it right away. Bottom line, it's very important that you know object-oriented programming for Android or anything else. So let's get into it. First of all, what is object-oriented programming? So object-oriented programming is a programming paradigm based on the concept of objects. So what is a paradigm? A paradigm means that it's a pattern. So basically, object-oriented programming is not something like a feature, or it's not something that is special to some languages, or it's that it means that there has to be something extra in a language, or it's nothing like that. So paradigm just says that it's a pattern of you writing code, and this pattern is based on something called objects. So basically, object-oriented programming is not a separate branch of programming, or it's not a separate way of programming and all. It's just you follow certain methods, or you follow certain best practices, or uh, certain ideas that are already in use to make your code good, or to make your development easy. So that is the main goal of object-oriented programming. It's just a paradigm. It's just the way of doing things, and it has got nothing to do with any extra features or anything extra. So the main aim of object-oriented programming is to bind the data and the functions that operate on them. So let's say I have to store the info of every student, or I use the info of every one of us to make an app. So there are certain properties like the department of a student, the year they started studying, and their serial number in class. So let's say I have these three fields. The first field is the department, and the second field is the year, and the third field is the serial number of you in your class. So object-oriented programming helps you have all of these stuff at one place. And let's say I want to extract your roll number from these data. So it has the functions that operates on these data in the same place as well. Let's say, like I said, we have these three properties, and I have another function called get roll number. So this get roll number would read through all of these data, and for example, let's say it takes my roll number, and first it finds what is my department. It's 1031, the first four numbers, and it checks what is my year of joining NIT. It then gives 17, and then it checks my serial number in class, and it appends it to the roll number that it already has. So then it gives the entire roll number. So basically, object-oriented programming is a way of having data and the functions that operate on this data together. So there are some main. It might not be very clear right now, but once you learn about the actual implementations of OOP, it will be clear to you. So there are some four main concepts of OOP, which include polymorphism, inheritance, encapsulation, and abstraction. Let's look at each and every one of them in detail. So before we go into them, let's look at what are classes and objects. You might have heard about classes and objects, but let's look at them once more here. Classes are blueprints for objects. This is very vague, I know, but classes are something like it's a skeleton or it's a design plan, or as it shows in PPT, it's a blueprint. So a class says how an object will be, or how it should be, or how it is meant to be. And objects are nothing but the instances of these classes. So let's take this example. Class dog. So this dog has a name, age, its breed, and a function called bark. So this is nothing but a class. Uh, let's say that this is nothing but a blueprint, right? Because a dog has a name, an age, and a breed. So yeah, so this is nothing but a class. Looking at an object, okay, I don't have the object right now. So let's say I have a dog named Roger. So that is nothing but an object. So this Roger is nothing but an instance of this class dog. It is one instance of this class dog whose name is Roger, whose age is, let's say, 5, and breed is something. So this Roger is nothing but it's an object and it's an instance of this class. So going back, classes are blueprints for objects. It tells you how an object should be. And objects are nothing but the instances or examples or live real world objects of these classes. So class represents a set of properties or methods that are common to all objects of the same class. So like shown in this example, the class represents the collection of properties which are nothing but name, age, breed, which are common for all the objects of the same class. And meanwhile, the objects, the all instances of the objects, they share the same attributes like the name, age, and breed, and they also share the same behavior of the class. Behavior in the sense you can take it as the function bark, and the only thing that is different between two objects of the same class is the values or the state of the is the values or the state of the object. So let's take two objects of the class dog. Let's say I have two dogs named Roger and Stark. So these two dogs are still these two objects are still belong to the same class dog, but they are two separate instances of the class dog. One has the set of values called Roger, Phi, and Beagle, let's say, and the other has a set of values called Stark, age 10, and Beagle. So these two objects belong to the class dog, but they are two separate instances of the class dog, and they are called two objects. I think it's clear for everyone. If not, you can interrupt me at any time and you can ask your doubts. So let's look at something called constructor. So constructor is a special type of subroutine called to create an object. A subroutine is nothing but it's you can take it as a function. So a constructor is nothing but a function you call to create an object. So let's say you have a class like which you saw previously called dog, and how do you create an object from the class dog? So you use a constructor to create an object from the class. So the job of the constructor is to prepare the new object for use, and the constructor often accepts arguments from the one that is constructing the object, and it can set the required values of the object while it is being created itself. So classes in Kotlin have a primary constructor and one or more secondary constructor. So the primary constructor is nothing but it's part of the class header itself. Like in the previous example, I've used class dog, right? So this in itself is a constructor. If you have known OOPS in other languages, you might have seen that you have another function which has the same name as that of the class, like dog. But in Kotlin, this same line is the same as the primary constructor. And one more thing about primary constructor is that it cannot contain any code. Sometimes it might be necessary to add some code in the constructor itself. Like let's say you have this class, and once someone creates or calls the constructor to create an object of this class, you might want to print that creating a dog or something like that. So if you want to do that, you cannot do that in your primary constructor. But instead, if your constructor does need some initialization code, it can be placed in one or more init blocks. So init blocks are nothing but blocks of code which would be called every time your constructor is being called. So these init blocks are called in the order of their appearance, and the class can also declare one or more secondary constructors which are prefixed with the keyword constructor. So I think if you look at an example, it might be clear to you. So let's take the class dog. You can see this resembles a function which takes an argument which is nothing but name. Like I said, in Kotlin, the class definition or the class keyword goes hand on hand with the primary constructor. So class dog means that the dog is that same line can hold the primary constructor as well. So it has one argument called name, which is nothing but of type, which is of the type string, and equals to Roger means that if a name is not provided, the name of the dog by default becomes Roger. So then we have the first line, which is nothing but the properties of the dog. First property is variable name, which is of type string, and you assign the name that you received as an argument to this property of the class, which is nothing but the name, which is the property of the dog. So then you have the init block. So let's say my requirement is that as soon as the dog is created, I have to print welcome the name of the dog. So like I said, you can't just simply write println welcome, the dollar name without having in the primary constructor itself. So instead, you use the init block if you want to have some code, some initialization code. So use the init block and you print this.
Hello, sir.
Yeah.
Doubt, sir.
Yeah. No need of sir. Just call me Mario. Yeah, go ahead.
Okay, it's little weird. Okay, so now if I don't give any input for the variable name,
Okay.
then in the println, instead of the dollar name, Roger will automatically come, or only what we give is going to come there?
See, if you don't give anything to the constructor, like while instantiating your object, so the constructor would see that there is no argument while creating the object. So what happens is that you have this name string equal to Roger, right?
Yes.
So in that step itself, the Roger would go to name will be assigned Roger.
Okay.
So in the second step, the var name string equals name. So the name on the right side is nothing but the argument to the function, which is
Okay.
nothing but
Roger.
Roger. So it
Okay.
gets assigned to the object that is being created, and so now the name of the dog that you created becomes Roger.
And
So
in
once
the
the
case
control
if
reaches
we
the init statement, yeah.
now if I have assigned some value to the variable name already, that would be given
Okay.
first preference, right? Not Roger.
No, when did you assign? Okay, while creating, right?
In the now in the main block, if I assign.
Okay, yeah. So then Roger would not come into picture because Roger is like a fail safe. It's like the default value. If some value is missing, or if the argument, or if the creator of the object doesn't give a name for the dog, then only the default value of Roger would come into picture. If not, whatever name you give for creating the object would be the name of the dog, and which would be printed with the welcome statement.
Okay. Thank you.
Okay.
In case we have to give the name for the dog, where we are supposed to give in a constructor.
Yeah, while calling the constructor, we'll look at it in the next slide. I think it comes in the next slide.
Sure.
Okay, so till now we have seen the primary constructor and the init statement. So now let's look at secondary constructors. So secondary constructors start with the keyword constructor, and then they accept another argument. So as you can see here, you can see owner, which is another variable of the another property of the class dog. So this constructor accepts something called accepts an argument called owner of the dog, and you can see next thing is you can see this. So what the keyword this means is that it calls the primary constructor again. So like you can see, this does not have any variable called name. It does not call the primary constructor with a, it does not call the primary constructor with a argument name. So what happens now is that the dog gets the name Roger by default. So every secondary constructor must have this, or it must call the primary constructor, which is done by the keyword this. And then you do the same thing. You assign the argument that was passed to your constructor, which is nothing but owner, to the property of the object dog. So this is basically the how you define the primary constructor, the init blocks, and the secondary constructor. You can have multiple secondary constructors as well. Now let's look at how to create an object. So you have some function make dog, which is inside some main function or somewhere. Just focus on the contents of the function make dog. So I have value star, which is the variable name of my dog of the object that I'm going to create, and then I call dog name equals to star. So what happens here is that you get an object called you get an object of the class dog, and the name of this dog now becomes star. So if I print println star dot name here, I would get star. Then what I do is I star dot name equals Tony. So I assign the name of the dog to Tony. So if I do println star dot name, I would get Tony. It's simple, right? So the same way, I create a new dog, which is called val Bruce. So Bruce is an object of the class dog, and I call now I'm calling the secondary constructor. Like you can see here, calling it simply just dog without any arguments being passed to it would call the primary constructor, and the primary constructor would give the default name Roger to it. Or calling dog with the argument name would also call the primary constructor, but calling it with the argument owner would call the secondary constructor. So here you have the constructor owner string. So this block would get called, and the first step what it does is this. So this is nothing but a call to the primary constructor. So again, there is no name that is being used to call this Bruce dog. So what happens is a dog gets created with the name Roger. So And since we pass once the primary constructor is called, so once the primary constructor is called, the name is assigned, the name Roger is assigned to the dog. Then what happens is the init statement gets run, so you have welcome Roger, and then the secondary constructor gets called where the name of the owner is assigned as the name of the owner is assigned as Wayne. So what happens if you print Bruce.name now? So what happens now is you get Roger. Then you can modify it to Bruce.name equals to Bruce. Then if you print Bruce.name, you would get Bruce, which you assigned previously.
I have
So
a doubt.
yeah.
Now in the first line, val star equal to dog bracket. Now we are passing the variable name. I mean, we are passing the value Stark into the variable name, right?
Yeah.
In the first
Yeah.
line.
Yeah.
So,
Exactly.
in the second line, we are changing that value, or that is where we pass it.
No. You see that dog. Brackets is the constructor. I mean, it's where you call the constructor and you create the object, right? So
Okay.
now you have an object called Stark. So this dog is already created, like you pass the name goes into it, and like it's there in this init statement, you just print welcome Stark and everything is done, and you have a brand new object, right? So
Oh yeah.
then you change the name of the object, I mean the property name to Tony.
Now instead of writing it in the second line, I can write dog name equal to Tony directly, right?
Yeah, that you can do that as well. I just wanted to show you that how to access, the properties of an object.
Yeah, and one more doubt. Now
Okay.
the variable name is inside that class dog.
Yeah.
I can access it anywhere throughout the program, or only, I mean, I can access it anywhere in the main function now.
Yeah. Inside this function that I've shown you, you can access it from anywhere.
Okay.
We will come to visibility modifiers in the upcoming slides. For now, just look at this like creating an object and accessing the properties of the object and accessing the members of the of these objects. So you now know how to create an object from a class. Now let's look at getters and setters. So as the name says, setter is used to set the value of any variable and getter is used to get the value of any variable. As you can see here, I have the variable name, which is of type string, and a function get, which would return name, and a function set, which has an argument called new name, which would set name equals to new name. So basically, as you can see from the code, a getter would just return the value of the name, and then the setter would get the new argument and put it inside the value of the variable. So this is a very simple use of getters and setters. But as your app grows in complexity and as your program gets much more complex, it is not desirable to directly access your variables like I did here. Like start.name equals to Tony. You have this code, right? So it's not very desirable to directly access these variables or these properties. So that's why we use getters and setters. And let's say have the dog, let's show you how the power or the use case of the getters. So as you can see here, the dog name is Roger. So let's say I want to, whenever someone accesses the name of the dog, let's say I want to return, if the dog's name is Roger, I want to return dog Roger. So what I would do is I wouldn't change the name of the variable at each and every place. What I would do, or I would not modify the structure of the class. what I would do is I would modify the getter function of the the property or the member variables of the class. So instead of get equals to name, I would write get equals to dog plus name. So by this way, whenever you try to access the variable name, you would get dog plus or whatever that way. So this is the use case of getters and setters. By default, Kotlin provides the default getter and setter that I've shown here. But if you don't want the default getters and setters and you want something else, you can just try out giving out your own, writing your own getters and setters. Yeah, like I said, it's not desirable to directly access your the properties or elements of a class. It is advised to just always create a getter and setter and only then access the member variables or the properties of your class.
What advantage getters and setters?
Sorry, I didn't get your question.
What is the advantage if you use getters and setters?
Yeah, so like I said, it is not advisable to directly access the properties of the properties of a class, because let's say I have a field called roll number. Okay, so if I allow people to directly access that roll number, let's say you have a code bug in your code, and the roll number is how many digits? It's 9 digits, I guess. So let's say by due to some bug, it gets it goes to 10 digits. So then the entire it just triggers another bug and it goes on. But that won't happen in the case of if you have getters and setters. So getters and setters would make sure that you follow a particular protocol to access and to modify that data. Right, instead of just giving free access to everyone and everything, you just restrict the access to well-defined methods or well-defined functions about how you can modify and read those values of the object. Fine. Okay. So it's just a precaution, or it's just a pattern of doing things. Like I said before, object-oriented programming is not a set of rules, or it's not at all what we call as syntax or something. It's just a pattern, or it's just a set of imaginary rules that have to be followed to make your code more and more easier and bug free or whatnot. So moving on to the next big chapter about OOPS is encapsulation. So encapsulation refers to bundling of data with the methods that operate on the data. This is one way of looking at encapsulation. And another way of looking at encapsulation is restricting access to some of the object's components. So encapsulation can be taken in two senses. The first sense is having data and the functions that operate on the data together. Like let's say I have a class called a box. So a box would have length, width, and height. So these are the properties of the box. Now I say that I want to calculate the volume of this box. So what I will do is I multiply the length, width, and height. So this class has the data called length, width, and height, and these data are bundled along with the functions or methods that operate on these data to give us a new or meaningful value. In this case, that function is nothing but calculating volume. So that is one way of looking at encapsulation, which is nothing but bundling data with the methods that operate on the data. And the other way of looking at it is restricting direct access to some of the object's components. Like I said, it is not desirable to directly access the variables or the properties of a class. So instead, encapsulation provides a shield, or it provides a coating around your object and it gives well-defined methods to interact with the properties of the object. So encapsulation, introduces a very important concept of visibility modifiers. So in Kotlin, classes, objects, interfaces, constructors, functions, properties, their setters and all can everything can have visibility modifiers. Let's look at what visibility modifiers are. So there are three main visibility modifiers. They are public, private, and protected. So if you say call a variable public, means that it can be accessed or it is visible outside the class. It can be accessed from anywhere, from any classes. So everything in Kotlin is by default public, and private means that it is only visible inside that class. Let's say I have two classes, cats and dogs. So the properties, if I declare something private, the properties of dog is visible only inside the object dog, and cat, the object cat cannot access a property of the object dog. Let's look at private is the same as protected is the same as private, but it is visible to the properties are visible to any subclasses that might exist. Don't worry about what a subclass is right now. We look at it in the upcoming slides. So basically, public means it's open for all. Private means it can be accessed only within the class, and protected means protected is the same as the private, but subclasses can also access them. Let's look at the examples of the visibility modifiers. On the left side, you can see the class outer. So we have a private val a equals to 1 and protected open val b equals to 2. Don't worry about the keyword open right now. We'll look at it in the upcoming slides. And there is something called internal. Don't worry, internal is not frequently used, so don't worry about internal as well. And then val d equals to 4. Since no visibility modifier is mentioned, by default it becomes public. And then you have protected class nested. So you have an outer class, and there is another class called nested inside the outer class. Fine. So that has a variable which is explicitly mentioned as public, and its value is 5. So now let's look at this subclass, subclass. And usually you would have seen you have variables and their types mentioned using this colon. But for making a class as a parent of another class, you mention the class next to the name of the subclass. Like you can see here, you have e colon int. The same way you have subclass colon outer, which means that the outer is the parent of this subclass. Fine. So from the class subclass, the variable a is not visible because it's private. So a can only be accessed from the class outer only. And B, C, D are visible because protected means that protected would mean that the variable is visible from the subclass, and D is public, so there is no problem in accessing D. And since the class nested is also protected, it is accessible by it is accessible by the subclass, and since E is public, it is also accessible here. And don't worry about the override right now. Let's look at it later. Now let's look at this class unrelated. So this class is just it's not related at all, and the object of the outer class is being passed to it. So you might assume that O.A should be visible here, But since A and B are private and protected, and unrelated is not a subclass of outer, O dot A and O dot B are not visible to it. And O dot D, since it is public, it is visible, you can access O dot D. And outer dot nested is not visible. And since E is inside the nested, it is also not visible. So if it's confusing right now, don't worry about it. You just come back to it later. You know, it will be clear to you. Just know that public means it's visible outside the class. Private means it can be accessed only within the class, and protected means that it is same as private, but any subclass can access it.
Hello, Mario, I had
Yeah.
a doubt.
Yeah.
Yeah, in this code, how is the class subclass different from class unrelated? Because is unrelated a part of a different program or something like that?
No, everything is part of the same program. Okay, but like I said, the subclass colon outer. Okay, can you see that? Class subclass colon outer. So this means that the subclass, the outer is a parent of the subclass. Fine.
Okay.
So this just means that the class subclass would inherit the properties of the class outer.
Okay, got it. And the
So
other one
outer is
inside
the
the
parent,
parenthesis
and
that I can...
one sec. So outer is the parent, and subclass is its child. So now the variables that are mentioned as protected in outer can be accessed inside subclass because it's a subclass of outer. But in unrelated, in the class unrelated, it is not a child of the class outer. Just an object of the class outer is being passed to it. It's just like passing a number, or it's like passing a string to the class, right? So the same way, an object of the class outer is being passed to it. And other than that, the class unrelated and the class outer does not have any link between them. So both private variables are not visible to unrelated class, and the protected variables are also not visible to the class from the class unrelated. Only the public variables can be accessed from the class unrelated. Fine?
Yes, got it. Thanks.
Okay. Okay, next let's move on to inheritance. Inheritance is nothing but a process where one class acquires the properties of another class. Since you already saw that example, the subclass acquired the properties of the outer class, right? So the same way, so that is what inheritance is all about. So with the use of inheritance, the information is more manageable in a hierarchical order. So the class which inherits the properties of other class is known as a subclass or derived class or child class. And the class whose properties are inherited, in the previous case the outer class, it is known as superclass or base class or parent class. So basically inheritance means it's a process of acquiring the properties of one class by another class, and the class which inherits these properties is called derived class or subclass or child class, and the properties and the class which gives out its properties or whose properties are inherited is known as superclass or parent class or base class. So in Kotlin, by default, the classes cannot be subclassed. So going back to this example, the class subclass colon outer is there, right? So it is not possible to do this by default. What you need to do is, in this class outer, you can see the keyword open, right? So you have to mention this class as open. Only then you can, derive, you can base class, and you can uh, inherit the properties of the parent class to the child class. Only if you use the keyword open, it is possible to inherit properties from that class. So in Kotlin by default, classes cannot be subclassed, and similarly, properties and member variables also cannot be, overridden by these subclasses, though they can be accessed. Like a subclass can access and modify these variables, but they cannot override them. Let's look at what override is later. So what needs to be done to allow these classes to be subclassed? You need to add the keyword open. So similarly, you must also mark the properties and member variables also as open in order to override them in the subclass. Don't worry about what overriding is or how it's useful. Let's look at them later. So basically, remember that for you to subclass a class, you need to mention open. So let's look at this example. You have open class dog, which has a name, which has open var name of type string, and open where name of type string equals name, which is nothing but any argument that is passed to the variable name is stored as the property of the dog and in the property name. Then look at the class beagle, which is nothing but another class called beagle, and it overrides the variable name string of type string and variable age of type int. Then you can see another colon, and dog name equals name. So basically this colon dog means that the class beagle is a subclass of the class dog. So dog is the parent class and beagle is the child class, right? So then what happens is that override where age, the age that was passed as the argument goes to the age. So the basic thing that you have to take from this is you have class, the subclass name and the arguments of the subclass, colon, parent class name and the arguments of the parent class. It's clear, right? How you define a subclass and the link between the parent class. Then how do you make a beagle? So val my beagle equals to, you call the constructor of beagle and you pass the variables. The first it needs a string. You pass Diana and the age has 1. So basically, this is how you create objects of the subclass. So creating, as you can see, creating the objects of subclass or creating the objects of class is the same as done before. And moving on to the next part, we have abstraction. Okay, before we go into this, just give me, any doubts?
Can a subclass also be private, public, and protected?
Yeah, it can be, yes.
Okay.
So any classes, any properties, any variables, any getters, setters, anything can be accompanied by a visibility modifier, and you can restrict its access to other classes. Okay, so before we go to abstraction, just give me a minute. After laptop is running out of charge. Yeah, sorry for the interruption, folks. Okay, let's continue with abstraction. So till now we have seen we have looked at inheritance and encapsulation. So now let's move on to abstraction. So what is first of all, what is abstraction basically? So let's say that a real life. Let's look at a real life example of abstraction. Uh, we all have traveled in car, so there are thousands and lakhs of product parts in a car which help in using the car, which help us travel, but we don't know how each and every part works. We just know that we have a clutch, brake, accelerator, and we have a steering wheel, and you turn the steering wheel left, your car moves left, uh, and that way. And you don't know the exact implementation or how each and every part works inside your car. But even then, you just drive your car, and even then, you know how to use your car. So that is the basic principle of abstraction. So what you do is you define you tell that this is the behavior that is expected, and you don't care about the implementation of what is happening or how it is done. So that is basically what abstraction means. So sometimes you want to define common behavior or properties to be shared among related classes. So Kotlin offers a way to do that, and it gives us two ways to do that. One is interfaces, and the other is abstract classes. So these might sound very confusing at the first, but let's look at them closely. So neither abstract class nor interface can be instantiated on its own, which means you cannot create objects of these types. So abstract class or interface, they are just basically they are classes, and they cannot be instantiated directly like we were doing till now. So if you define a class as abstract, you cannot call the constructor directly and expect to have an object then and there. So abstract classes, they have constructors, and interfaces can't have any constructor logic or store any state. Like I said, the name, the age, and all were the state of the object. And interfaces, can't have any constructor logic, or they do not store any state. Now let's look at an example of an abstract class, which is nothing but abstract class caller, and it has a variable abstract where color of type string. So basically, this is our abstract class, and you have class plastic, which is another class, which uses which is a subclass of the abstract class caller, and you override the variable color and you assign it value gray, and you have another class called wooden, which is also a subclass of the caller, and you override the color of this class to brown. So basically, you have two types of callers, and you just define the behavior or a pattern in these two different classes, which is nothing but the variable color. So let's go back to the definition of abstraction. Sometimes you want to define a common behavior or properties to be shared among some related classes. So the class plastic collar and wooden collar are two related classes. So you define an abstract class called collar, to define the properties that are common to these two classes. This might sound vague, and you might think it is very unrelated right now, but it's really really useful, and it might not look like it now, but just let's keep going through it.
Hello.
So that basically, yeah.
Like, how do we define a subclass and also use abstraction?
Sorry, what?
How do we define a subclass and also use abstraction?
like the way I have shown you here.
Like previously we defined a subclass, right?
Yeah.
And
So
if you want to use abstraction in that subclass, like how do we define it then?
then you just write abstract class, plastic, and color.
Okay.
So this is just for your example, like something that I just wrote because it has to be very simple for you to understand. At the beginning, you don't have to worry about very minute details and all. Just understand what is meant by abstract classes and all. Once you get into coding your way into Android, you might come across many examples, and then you can learn about them in depth. Now let's look at what, since we have looked at the definition of abstraction, let's look at what polymorphism is. So polymorphism is nothing but it's the ability to take on many forms. It might be expanding the functionality in a class after inheriting from a base class, or overriding methods in the derived class. So let's take an example of a class shape. Okay, so this shape, it can have many shapes like rectangle, circle, or triangle. So each of these shapes will have a common function called area. So what is the area of a circle? It's pi r square, and an area of a square, it's side square. So each of these different shapes, have the same function called area, but different implementation of this area. So this is where polymorphism comes into picture. So the function area can have many forms. One is side square, other is pi r square, and other is half into base into height. So this is basically the definition of polymorphism. It can also be extended to, there are many types of polymorphism and many instances of polymorphism in a language, but let's just keep it simple right now. Just remember this example. And we're good to go with polymorphism. Since we looked at abstract classes, and like I said, another way of defining common behavior or properties other than abstract class is an interface. So let's take an interface that is not dog action. There is a correction here. It's interface action. Fine. So interface action. So it has certain. It defines certain behavior. Function eat, function jump, function clean, and function swim. You just println and swim. So basically, like I said, this interface action just defines a set of common behavior between dogs and cats. Fine, right? So what happens is that, as you can see here, class dog colon action. So the difference between implementing. So basically, when it comes to interface, you call them implementing. Fine. When it comes to subclassing, it becomes extending. So this line should be read as class dog implements action. Fine. So in the previous case, in this case, you have to say it as class plastic extends collar. Fine. So when you are subclassing a class, it becomes extending, and when you use a interface, it becomes implementing an interface. So basically, class dog implements the interface action, and you override function eat. You return println yum, and then the class cat, and it also implements the same set of action. You override function eat. You println yuck. So basically, you had the same function eat. So the interface action, it defines the same behavior, which is nothing but eat, and you override the eat function inside the class dog to print yum, and you override the function eat to print yuck. So basically, this is another example of polymorphism, and another example of how the interface and abstract classes work in Kotlin. So you have a set of behavior common to both dog and cat. So instead of defining them, or instead of writing code for them separately, so the interface provides a way, or provides a structured approach to how you handle this behavior that is common between dog and cat. So this might not look like a big issue right now, but once you get into development, interfaces in the abstract classes would play a good role in making apps that are really great. So abstract
So,
classes and interfaces, yeah.
sorry to interrupt. Is it like switch function in C++?
No, 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 no. So basically, it's nothing related to switch function. So basically, let's say I have a function, I have a class called dog, and I have a class called cat, and also I have a I have a class called let's say peacock. Fine. No, I don't want peacock. Let's say I have a class called penguin. Fine. So what happens here is that there are certain set of behavior common to dog and cat, and there is a certain set of behavior which might be common to cat and penguin, right? So I have to define these behavior alone, and I need not worry about the implementation of these details. Like I said in abstraction, you just want to know, you just want to say that if you turn the steering wheel left, your car turns left, and if you steer it right, your car turns right. And I don't care about how it does it; it just has to do this. So I want to define, I want to define the set of behaviors without mentioning how these details are implemented. Okay, so that is where the interface comes into picture. So I want to define certain actions that are common to dog and cat, but I don't want to implement those actions. So that is where I use the interface action, and I define some common behavior of cat and dog, which is nothing but eat, jump, clean, swim. Fine. So another set of, I can have interface, action. Instead of action, I have hunt. Let's say I have interface hunt. So in this hunt, let's say I have a function called catch fish. So catching fish might be common to cat and penguin, or some other animal. So this way, I just define that these functions or these behaviors are there, but this is not. I don't care about the implementation right now. Fine. It is the duty of the function that, it is the duty of the class that is implementing these interfaces to define how this function is going to work. Okay, so basically interfaces and abstract classes are a method of saying that your class has to do this, but I don't care about how it is implemented. Cool?
Yeah, thanks.
Okay. So it might not be clear right now, but once you look at actual examples of how interface and abstract classes are used, and then you come back and look at the definition of them, it might be very clear to you. So moving on, abstract classes and interfaces are two ways to share common behavior between classes. So the main aim of why abstract classes and interfaces are present is to share common behavior between two classes. An abstract class defines properties and behavior, but leaves the implementation to the subclasses. So abstract class just says that these are the properties and these are the behavior I expect, and you have to implement these behavior by yourself. It says that to the subclasses. So the interfaces also defines the behavior, and it might provide some implementation, for some of the behavior, and it might leave the implementation to the subclasses for the rest. So if you don't understand about abstract classes and interfaces right now, you just go through it again or look at some other examples, and I hope it becomes very clear to you. Yeah, I think that's it for today. Like these are the main concepts of object-oriented programming, and like always, you will have the recording of this session and the slide posted in the Discord channel. And also, there is no MS Teams. Also, there is no MS Teams for the Android Study Jams. Is that it's just the same link that you use to join every day. So yeah, I guess that's it. If there is nothing else, you can, if people can leave the meeting. And we are done for today. Just make sure you go to the course that is mentioned in the slide, and you, you get your badge. Thank you, guys. Have a good day. If you have any questions, you can ask, or you can, you're free to leave.